Good morning, friends. Let us see video number 66. In this video, today we are going to take QR. Again, familiar word. Quick revision of chapter number 1. We have seen this chapter plenty of time. Maybe more than 3 or 4 times. That is okay. Right? Then also, as a part of revision of your unit test, we are going to take quick revision of chapter number 1. Okay? Chapter number 1 starts from one very nice theory, and it is nothing but Coulomb's inverse square law. Coulomb's law. Inverse square law that we will discuss afterwards. Coulomb's law we have seen in two forms. Scalar form. What was there in a scalar form? So it was very easy. The force acting between any two charges. The force acting between any two charges is directly proportional to product of their charges Q1, Q2 and inversely proportional to the square of the distance between them. Right? So, this is the equation, and from that we have to write the statement. Again, force, two charges, same charges, so obviously that force may be a repulsive force, not maybe, must be repulsive force. So here that what you have to include, the repulsive force acting between any two charge is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Second statement, and this force is directed towards the line joining their centers. Clear? Okay. If you want to remove this proportionality sign, then you have to put a constant, and that constant is given by small k. Got it? And what is small k? Where small k is nothing but 1 upon 4 pi epsilon 0. And what is epsilon 0? It is permittivity of a free space. And its value is 9 multiplied by 10 raised to 9. K value, its unit. Take r square here. So force is Newton r square. R was the distance, and because of that it is meter square. Coulomb will go here, it will go up, so it is Coulomb minus 2. Clear? So this is a scalar form. When it is asked as a 2 marks, you have to explain each and every term. For an example, what is k, what is epsilon 0, how the unit and dimension formula can be obtained of epsilon 0, and from that k. Clear? So this is a scalar form. Now if you want to write this in a vector form, then it is like this. Force acting on a charge 1 due to second. Same equation is there, is equal to value of k 1 upon 4 pi epsilon 0 multiplied by same q1 q2 upon r square. Clear? This is the force acting on 1 due to second. So you have to write that unit vector also r12. Here also r12. Clear? Now, what is this r12? So, r12 is equal to R1 minus R2 and unit vector R12 is equal to R1 minus R2 upon in modulus R1 minus R2. So put these two here. First R12 and then this. You will get 1 upon 4 pi epsilon 0 multiplied by Q1 Q2. This term in bracket, that is R1 minus R2 upon value of this, that is R1 minus R2 square. For this again there is the same term, so it is R cube. Okay, so this is the Coulomb's law in a scalar form as well as vector form. What is Coulomb? It is a unit of charge. Now it is very easy. Few things we don't have to revise because it is now our routine. Clear? So this is about Coulomb's law. Coulomb's law is known as inverse square law. Why? Because you can say that from this equation we can say that F is inversely proportional to 1 upon R square. What is R? R is the distance. So as distance increases, repulsive force decreases. Because of that, inverse square law. Coulomb's law is known as inverse square law because the repulsive force acting between any two charges is inversely proportional to the square of the distance between them. Clear? Okay? Now, from the same equation, we can define electric field. What is electric field? It having symbol capital E and it having equation F by Q. What is F? Same Coulombian repulsive force. Right? From this, its unit, it will be very easy. Now, force. Newton, take Q upside, that is charge having unit Coulomb upside means Coulomb minus 1. Right? From this, its dimension formula also. Newton means force. In 11th standard, we have prepared MLT, that is 112 minus. So it is of Newton. Coulomb means A1 T1, but there is a minus 1, so it is A minus 1 T minus 1. Got it? Now reshuffle this equation, rearrange, that is M1L 1 T minus 2 minus 1 minus 3 A minus 1. Clear? Now put the value of F. You will get what you will get. K, same. Let us take same charge. That is instead of Q1. Now let us take Q. Instead of Q2, let us take Q. So it is Q square by R square divided by Q. So 1 Q will be cancelled out. So it is like this. KQ by R square. And put the value of K. You will get the equation of E. E is equal to, that is Q, value of K, 4 pi epsilon 0 multiplied by R square. Okay, this is we have seen in our regular school also, because this was already completed before that lockdown. Clear? So here also you can see that electric field is inversely proportional to R square. So as R increases, electric field decreases. Clear? So on the same board, about Coulomb's law, scalar form, vector form, and about that unit, dimension formula, equation. From the equation definition, what is the definition of electric field? So from this you have to write the definition, and definition is like this, that is Coulombian repulsive force acting unit charge. That is the electric field. Okay, Newton Coulomb inverse. There is one more unit. Which one? Volt meter inverse. Okay, it is there in our regular notebook. Clear? So have a look for few seconds, and if you want to take screenshot, I will move from here. Okay. Okay. Now there is magnetic field. Magnetic field, its characteristics. So they are very easy to understand, and no need to. I don't think so. We have to take it as a revision, right? If you will read, it will be very easy for your understanding. 7 or 8 characteristics are there, so you can prepare easily without any help, without any revision. Okay, now let us see about what is electric dipole. Got it? Electric dipole. So what is electric dipole? That we know very well. Two equal and opposite charges. First charge, that is Q. Second charge, Q. Equal and opposite. First charge minus second charge plus. They are separated by some definite. So what is this? It is the distance. So very easy. Two equal and opposite charges. Got this sign? Two equal and opposite charges are separated by some definite distance to form electric dipole. And if we are taking this distance 2a, then we have new definition, that is electric dipole moment. Okay, so electric dipole moment having symbol P, having equation which 2a, distance multiplied by charge, that is Q. Okay, from this its unit, it is very simple. Q, charge, that is Coulomb. 2a, that is distance, meter. Okay, and from there its dimension formula. Coulomb means A1, T1, again meter, that is L1. So you are having, what we are having, mass 0, L, 1, T, 1, A1. Okay. Now what is the definition of electric dipole moment? You don't have to write that equation, but before that you have to write the statement. If two equal and opposite charges are separated by a distance 2a, then electric dipole moment is given by this equation. Clear? Okay. Its unit and dimension formula for a short question. From this only, there is one more thing. It is point dipole. Got it? What is point dipole? In this equation means P is equal to 2a multiplied by Q. In this equation, we have to take what? If 2a tends to 0, means this distance we are taking 0, so the charges will be at a 1 point. If 2a is equal to 0 or Q, charge, let us take infinite. If 2a is equal to 0 and Q is equal to infinite, at that time the dipole is said to be a point dipole. Right? So this is the condition for dipole. Which dipole? Point dipole. Clear? Okay. Then after we have seen for a dipole two equations we have seen. First one was for axis and second one it was for equator. Okay, so what was the question for that? Obtain the equation of electric field at a point on the axis of dipole. Find out what was the equation. So E is equal to, what was that? 2 Kp upon 4 pi epsilon 0, then in bracket, what was that in bracket? Okay, it was nothing but r square minus x square whole square. Clear? Any doubt? No. Okay, then the same equation for equator, but we have already discussed from here to here how to come. Then E is equal to entire term, it is plus, so here you have to take minus 2, you don't have to write, that is Kp upon 4 pi epsilon 0 r square minus x square. So if it was plus, here we have taken minus. If it is minus, you have to take plus raised to 3 by 2. Okay? So symbol will be different. X square minus x square, in our textbook it is y square, but it is the same. Clear? Then after, what we will take? Okay, here for your screenshot, if you are taking, let us take one more thing, that is about electric flux. What is electric flux? Electric flux having symbol phi. Phi is equal to E, that is E dot A. Okay, and E dot A, there is a dot product, so you can say that electric flux is a scalar quantity. There is a dot, so you can write that is E A cos theta. What is theta? It is an angle between electric field and A. A बोले तो area. Clear? From that, its unit and dimension formula, unit of E, Newton Coulomb inverse, that is Newton Coulomb inverse. A means area, that is meter square, and it is invented by one scientist, that was Weber. Clear? So this is about electric flux, and if it is asked as a 2-mark question, then you have to explain the condition here. Which condition? You have to take first theta is equal to 0, then theta is equal to pi by 2, then theta is equal to 180. Right? In this three case, what will be the value of flux? Here maximum, here 0. Why? Because cos pi by 2 is 0. So flux is 0. And same way, theta is equal to 180. That is minus 1. So the flux is inverted. Clear? So have a look for this quick revision of electric dipole moment, point dipole, electric flux, dipole. These two are the 2 marks theory. Or if depends on your examiner, it may be asked as a 3-mark theory also. Have a look. Now there is a turn off, which there is a turn off linear charge density. Got it? What is linear charge density? Got that idea? La. La बोले तो lambda. Lambda is equal to charge density. Charge means Q by linear means line. Q by L. Okay? So the amount of charge distributed per unit length is known as lambda, linear charge density. It having unit. Which unit? Charge, coulomb, length, meter inverse. Okay? Same way, instead of linear, surface, charge, density, surface, बोले तो sigma is equal to Q, as it is surface having area, so Q by A. So you are getting Q, coulomb, its unit, A, area, take it up, so it is M minus 2. Same way, last one, that is volume charge density, right? Volume itself indicated by rho is equal to Q by V, and it having unit coulomb V, that is M minus 3. So this question was asked before 2 years in that final exam about surface charge density. Define surface charge density, give its equation, unit and dimension formula. It was the question of 2 marks. It's okay now? Okay. Now let us see one of the most important equation of Gauss law. What was that equation? First of all, I am writing the equation, then after you have to think about the statement. What was that equation? It was like this. Okay? Now, think about the statement. What will be the statement? Electric flux associated with a closed loop, phi. What is phi? Here it was there. Okay? Phi. Electric flux associated with a closed loop is a ratio of total charge enclosed to epsilon 0, and we know that what is epsilon 0. So from that equation plus statement, 1 mark, and if it is asked as a 2 mark, it will be your homework, writing homework in assignment. Okay, with the help of Gauss law we have obtained equation of electric field for a long wire, right? E is equal to, here what will come, that you have to obtain at your home by your own. Second, for plain sheet, got it? Plain sheet, E is equal to, and this equation is very important in second chapter also, you know very well, and it was E is equal to sigma upon 2 epsilon 0. And what is sigma? Sigma is nothing but surface charge density. Right? Then last application of Gauss law was about that shell. Shell was there or sphere? Yes. Sphere. As for a sphere, we have obtained two equations, that is inside and outside. What is the equation inside and what is the equation outside? Again, 2-mark theory. Mind well, this theory is deducted from that CBSE guideline. But previously also I was telling that we have to wait for our government notification. Clear? So, this was the quick revision of chapter number 1. Mind well, for the same theory, from the same chapter, you must have to appear for unit test as well as in government test. So, for that, you have to prepare well this chapter number 1. Numericals are also too easy. So, please prepare well